All right, as we continue to look at quadratics, we're going to start looking at the graphs of quadratic functions. Now, we've kind of saw this when we talked about transformation and function families last chapter. We know that anything typically that looks like y equals x squared is going to make some kind of parabola. So we talked about shifting these and flipping them and stretching them and all those kind of good things to make different kinds of parabolas. So we're going to kind of talk about some parts of the parabola, and then eventually we'll find out how to algebraically find these. So you basically have two types of parabolas. You have ones that open up, like this one, where we have the two ends going forever, and then we have this minimum value at the bottom. And then you have the ones that are upside down that have a maximum value and that point down in both directions. Okay? So, a couple key points that you have on both of these. All parabolas have a y-intercept, as you can see here. All parabolas will have a vertex, which is either the minimum or maximum, depending what we're talking about. And then they will also have x-intercepts, possibly. Now, this is not a requirement, because you can imagine if we have an axis here and our parabola looks like this, well, now there is no place where it crosses the x-axis, so there are no x-intercepts. We're also going to talk about a special line. The special line is going to be this line that kind of cuts it in half. So we'll talk about this line as well. And we refer to this line as the axis of symmetry. It's the axis of symmetry because it's the line x equals some number that would split the parabola in half. So we're going to try to find all these algebraically and then kind of figure out what they mean as part of different application problems, vertical motion, and different things like that. So, obviously a couple things we just talked about. So quadratic functions we're really looking for, again, is going to be any function that's in the form f of x equals a x squared plus bx plus c, that is going to be a quadratic function. So it's going to look like the things we have above. Now, vertex form is something we've actually seen before. Sometimes this is also called transformation form. So if we take our typical old parabola, our x squared, and we can shift it left and we can shift it right, shifting left and right will actually find our vertex for us. So the vertex form of a parabola is ax minus h squared plus k. And the nice thing about this is going to yield us a vertex every time of simply hk. Okay? Because we're going to shift right h and up k in this case, so that's where my vertex is going to travel. Now the x-intercept, or the intercepts in general, we talked about above. That's just simply the points where the graph crosses the axis. And that could be x or y axes, so those are fine. And then the axis of symmetry, that's the line we talked about earlier. That's going to be the vertical line that splits the parabola in two equal parts. So it's going to have kind of two equal sides. They'll be equal distant from this line. Now again, we have to be able to eventually find these algebraically. The nice thing is, if you think about a parabola like this, now if you talk about transformation form, where this is h and this is k, then we could actually just think of this axis of symmetry as x equal h, because it's going to be this vertical line that goes through there. Okay? Now, getting in transformation form sometimes is tricky, but if we have that, we know it has a vertex of x equal h and a vertex of hk. So let's look at a couple examples that are dealing with vertex form. So obviously, if you remember some of our transformations, we can do things like this. So if we have some function y equals x squared plus k, remember this is going to shift up by k units. And obviously, if it's negative, it's going to shift down that number of units from our base quadratic. So if you remember our base quadratic, we could put some points on here, 0, 0, 1, 1, negative 1, 1, and kind of make our nice parabola like that. So if I want to use my, my transformation, say on this one, we know it goes down 3. So my vertex is simply going to go to 0, negative 3. Because it starts at 0, 0, that's the vertex of my traditional one, and I'm going to move it down 3. So 0, negative 3. And then we kind of know that the other ones are going to follow this same suit, and so our parabola would look something like this. Now for the next one, we have x squared plus 5. That's going to be a shift up by 2. So instead of our vertex being at 0, 0, we're going to shift it up to 0, 2, because that's our k. So 0, 2 is going to be our vertex. Now all of these are just opening nice and upward because none of them are negative. We know negatives are what transforms them. So we have these values here, and so it looks something like this. So with no h, we're simply just shifting it up and down, and that's just going to change our vertex accordingly, just simply by moving it up. All right, so if we do have the h value, remember h value is going to shift at the opposite direction. So generally this is going to shift either left or right, and it's always the opposite sign. So remember, if it's minus, it's going to shift to the right, and if it's plus, it's going to shift to the left. And that's going to obviously influence the x part of the vertex. That's why this will give us our x part of our vertex. So in y equals x minus 5, we're going to shift right 5. And so instead of our vertex being at 0, 0, it's going to shift over here to 5, 0. Now there's no shift up and down, so it's just going to affect the x in this case. And then we can go ahead and put our different values, kind of up one and over one to kind of complete our parabola. So it's going to look something like this. And then finally, the next one, we have y equals x plus 2 squared. So that's going to shift it left by 2. So instead of being at 0, 0, we're going to go over here to negative 2, 0. So our new vertex is going to be negative 2, comma 0. And it's going to kind of follow that same pattern as we see here. So we can move left and right when it's inside. Remember, it's always the opposite in vertex form. And then we can shift it up and down by adding or subtracting to the end. And that's always going to be our y value, our vertical shift. We can also put this together. We can also put them together by shifting right, left, and up, down. So this one, y equals x minus 4 squared plus 3, we're going to shift right by 4 and up 3. So my new vertex, starting at 0, 0, moving it over 4 and up 3 will be at 4, 3. So over 4, up 3. And so this one will look something like this. Obviously, you could check this on Desmos and figure out what it is. But you could also find the axis of symmetry here by kind of putting this vertical line here. We didn't do it on the others. But the axis of symmetry is going to be x equal 4, because that line is the line that's going to cut it in half. The nice thing about this, you can see there are always point equal distance on opposite sides of that line. So if we look at the next one, we have x plus 3 halves, which is left 3 halves, and then minus 1, which is down 1. So our vertex is going to simply become negative 3 halves and negative 1. So negative 1.5 down 1. So it'll look, I don't know, something like this. So it looks something like this. Okay? So we have an axis of symmetry here. We kind of split it down the middle right here at x equal negative 3 halves, because that's going to go through the vertex. So if you have it in this vertex form, it's really, really easy to find the vertex. Our problem's going to come in future sections is what if I have it in the traditional form? What if I have it in 2x squared minus 3x minus 4? I really can't see how it moves left and right from this form, so I'll have to figure out how to take it from this to something that looks more like this. So just a little bit about the graph of a parabola. Obviously, if you have questions, please let me know.